41,000 feet, a warning light said the left fuel pump was losing pressure. Seconds later, the right side warned too, then one engine stopped, then the other. 69 people were now inside a wide-body jet with no engine power and no destination it could reach normally. 17 minutes later, the aircraft was on the ground. Everyone was alive. The landing would make Air Canada Flight 143 famous as the Gimli Glider. But the flight did not run out of fuel because one person forgot to fill the tanks. It began with blank gauges, a number without a unit, and a check that repeated the same mistake. The Boeing 767 was new, digital, and one of Air Canada's first aircraft built around metric fuel quantities. Its fuel quantity processor had 2 channels. Earlier trouble with that system had already created confusing maintenance history. By the time the new crew reached the cockpit in Montreal, the fuel gauges were blank. The official inquiry concluded that the aircraft should not have departed in that condition. But people believed an exception was possible, and the fuel on board could still be measured manually. Under each wing were drip sticks. Pull a stick, read the fuel depth in centimeters, use a table to convert that depth into liters, then convert liters into kilograms. The procedure looked measurable. The responsibility for completing it was not clearly assigned. The stick showed 3,924 liters in one tank and 3,758 in the other. Total, 7,682 liters. To turn volume into mass, the crew and maintenance team asked for the fuel's conversion factor. The answer was 1.77, but 1.77 meant pounds per liter. The aircraft and flight plan needed kilograms. 7,682 multiplied by 1.77 produced 13,597 pounds. That result was treated as kilograms. Subtracted from the minimum required 22,300 kilograms, it left 8,703. Divide that by 1.77, and the answer appeared to be 4,916 liters. It was rounded to 5,000 liters and pumped aboard. The inquiry calculated that the correct uplift was about 20,000 liters, roughly 4 times as much. The arithmetic had been checked. The unit had not. Flight 143 flew from Montreal to Ottawa, where the fuel was measured again. The second check used almost the same conversion factor and repeated the same pounds versus kilograms assumption. Because the result looked like the number everyone expected, it created reassurance. The flight management computer was then given the assumed fuel mass. With blank gauges, there was no independent display to contradict it. Hours later, the low-pressure warning appeared and the crew turned toward Winnipeg. Within minutes, the left engine failed, followed by the right. By then the aircraft was around 35,000 feet, 65 miles from Winnipeg and 45 miles from Gimli. The main electronic displays went dark. What remained were basic standby instruments, altitude, airspeed, direction, and a rapidly shrinking piece of sky. Winnipeg was too far. Gimli was closer, a former Royal Canadian Air Force base that First Officer Maurice Quintal knew from his military service. Captain Bob Pearson also knew how to fly gliders. Those 2 pieces of experience suddenly became the aircraft's navigation system. Without normal power, the crew could not use the flaps and slats that would usually control approach speed and descent. Quintal repeatedly combined distance information from controllers with the aircraft's changing altitude to estimate a glide profile. Pearson had one approach: too low, and the aircraft would never reach the runway; too high, and there was no engine power for another circuit. The runway was 7,200 feet long. The silent aircraft kept descending. The former base was no longer simply an airfield. Part of the runway had become a motorsports drag strip, with drivers, families, cars, tents, and caravans near the far end. On final approach, Flight 143 was still too high and too fast. Pearson used a side slip, crossing the controls so the aircraft descended more steeply without gaining the same forward speed. It touched down within about 800 feet of the threshold. The main landing gear had locked, but the nose gear had not. It collapsed, scraping the nose along the concrete and adding drag. The aircraft stopped before reaching the crowd. Both fuel tanks were dry. The passengers and crew evacuated. All 69 people survived. The landing was extraordinary. The failure beneath it was ordinary in a more dangerous way. A component fault blanked the gauges. An aircraft departed when the inquiry said it should have been grounded. An abnormal calculation had no clear owner. People who had not been trained for the conversion tried to help one another. A factor arrived as 1.77 without its unit attached. A second calculation repeated the same assumption and looked like confirmation. The official inquiry treated these as connected human, equipment, procedure, communication, and corporate failures, not one careless mistake. Independent checks only protect a system when they are truly independent. Redundancy only works when the second path can disagree. And a number without a unit is not data. It is an accident waiting for context. Fault cascade. One fault, every consequence.